But before a finished steel coil ever leaves this factory, it passes through an extraordinary chain of fire, pressure, chemistry, and precision. Every ton of steel begins with raw materials arriving at the mill. One of the most important iron ore, the source of the ingredients, bliss-worthy iron that will eventually become steel. The furnace can begin its work. These materials must first be prepared and carefully controlled. The goal is simple. Prepare the right materials in exactly the right proportions for the furnace. From here, the materials begin their journey toward the most imposing machine in the entire process, the blast furnace. This towering furnace will use extreme heat to separate iron from the materials surrounding it. Prepared materials are lifted high above the furnace and carefully charged into its interior. Deep inside, the real transformation is about to begin. At the bottom, enormous blasts of heated air drive the chemical reactions that make iron production possible. Limestone. These hot blasts push temperatures high enough to melt and reduce the iron-bearing material. As the charge descends, oxygen is stripped away from the iron-bearing material, leaving the iron behind. Coke supplies both the intense heat and the chemical power needed to reduce the iron. Limestone plays another critical role, helping capture impurities and form the molten slag that will later be separated. At the bottom of the furnace, the transformation reaches its most extreme stage. Iron becomes molten. Because they have different densities, the molten iron settles beneath the slighter layer of slag. Once enough molten material has collected, the furnace and material is ready to release its products. The furnace begins the next its hearth. With the tap opened, thousands of degrees of molten iron pour from the furnace. This liquid iron will now leave the blast furnace and travel toward the steelmaking shop. Carried in a massive torpedo ladle, the molten iron begins its journey to the next stage. But the iron is not ready for steelmaking yet. First, unwanted elements must be removed. At the treatment station, the hot metal is prepared for the demanding chemistry of steelmaking. One important target is sulfur, which must be reduced before the iron enters the steelmaking furnace. The treatment material reacts with sulfur and other unwanted elements, pulling them away from the iron. The unwanted slag is removed, leaving cleaner hot metal, ready for the next transformation. With the major impurities reduced, the hot metal can finally enter the heart of the steelmaking process. Now the molten iron is ready for its most dramatic transformation, from hot metal into steel. Inside this enormous vessel, iron will finally begin its transformation into steel. The basic oxygen furnace is built to withstand an environment of extraordinary heat and violent chemical reaction. Before the hot metal enters, the furnace receives another essential ingredient: recycled steel scrap. Scrap steel is charged first, recycling existing metal back into the manufacturing cycle. The scrap forms the cooling foundation for the extremely hot molten iron that will soon enter the furnace. Now the molten iron arrives, still carrying the extreme heat of the blast furnace. Thousands of iron now pour onto the scrap, instants of degrees of beginning the next stage of transformation. The hot metal transfers its enormous heat to the scrap, helping melt it into a single molten bath. Together, the hot metal and scrap form the molten bath that will now be chemically refined into steel.
Everything is now ready. The next step will unleash the oxygen that turns molten iron into steel.
The lance must be positioned with extraordinary precision, close enough to react with the bath without touching it. Now the lance is exactly where it needs to be. Seconds later, the furnace will come alive.
High-purity oxygen is now routed through the massive lance
At tremendous pressure. Then the oxygen hits, and the chemistry changes instantly.
violently with carbons dissolved in other elements.
Carbon combines with oxygen and leaves the bath as gas, dramatically changing the composition of the metal. As impure oxidize, they combine with fluxes to form a foamy slag that rises above the steel.
Carbon, silicon, manganese, the purities, and other impurities are being driven out of the molten metal.
Every second matters. Too little refining leaves impurities behind. Too much can damage the final steel chemistry. Operators carefully control oxygen flow, watching temperature, chemistry, and the behavior of the bath. Operators constantly monitor the furnace to keep the reaction within precise limits. Thousands of data points help determine exactly when the steel is ready. As the refining progresses, the molten bath closer to the precise chemistry required for the final steel grade. Once the chemistry reaches its target, the oxygen flow is brought under control. The violent refining reaction is ending, but the steel still needs to be checked before it can move forward. Is the temperature question? Is the chemistry exactly where it needs to be? To find out, the steel makers take a precise temperature reading and a sample of the molten bath. Measuring the extreme temperature of this. Along with temperature, the sample will reveal whether the steel's chemistry has reached the required specification. That tiny sample represents thousands of tons of steel, and it must meet an exact chemical specification. Chemical analysis now tells the steel makers exactly what remains and what still needs to be adjusted.
If the chemistry is slightly off, the steel can still be corrected before it leaves the furnace.
Precise alloy additions can fine-tune the chemistry and give the steel the properties its final application requires. These carefully measured additions bring the molten steel closer to its final grade.
The molten bath is now approaching the exact chemical balance required for the next stage.
The refined steel is now transferred into a ladle, where its final temperature and chemistry can be precisely controlled. The ladle now carries refined molten steel towards secondary metallurgy, where the final details will be perfected. At furnace, the electricity and precise alloy control bring the steel to its final temperature and chemistry. Powerworks now heat the steel, giving operators precise control over its final temperature. Unlike the violent oxygen blow, this stage is controlled with remarkable precision. Small additions of carefully selected alloys can dramatically change the strength, toughness, and performance of the finished steel. Gas stirring circulate in steel, helping temperature and chemistry become uniform throughout all. Temperature is checked again and again because even a small deviation can affect the final product.
Samples are analyzed to confirm that the steel meets the exact specification ordered by the customer.
Once the numbers are right, the heating stops, and the steel is ready for casting. With the chemistry and temperature locked in, the molten steel leaves secondary metallurgy for continuous casting. Once the numbers are right, the heating stops, and the steel is ready for casting. Ahead is the continuous caster, the machine that will turn liquid steel into a solid slab. After hours of chemistry and heat control, the liquid steel is finally ready to become solid.
The molten steel enters a smaller vessel called the tundish, which controls its flow into the casting molds.
From the tundish, carefully controlled feed the casting molds continuously.
Inside the water-cooled copper mold, the outer surface of the liquid steel begins to solidify almost instantly. Powerful waters rapidly cool the shell, while the liquid core remains hot inside.
Rollers support the growing strand, guiding it through the caster while cooling continues.
By this point, the steel has become a continuous solid strand, still extremely hot, but strong enough to move on its own.
Once the strand reaches the required length, it must be cut into manageable slabs. Until the continuous is separate, cutting the strand into individual slabs. Has now become a solid slab for the next stage of rolling. These massive slabs now leave the caster and enter the next stage of journey. Massive cranes move the slabs with extraordinary precision, preparing them for reheating and rolling. The slab is reheated until the steel becomes hot and workable enough to be dramatically reshaped. At correct, the glowing slab moves directly toward the rolling mill.
Now the real reshaping begins. Massive rolls squeezing the slab, reducing its thickness with every pass. Pass after pass, the steel becomes thinner, longer, and more uniform, transforming from a massive slab into a continuous strip.
From raw earth to molten iron, from liquid steel to a finished coil, this is how America's steel is made.